Welcome to Math Challenge 655. In Math Challenge, we have an equilateral triangle and a semicircle drawn on the base. Now note that the base is not the diameter. The base of the triangle is not the diameter. The diameter is smaller than the base, but the diameter lies along the base of the equilateral triangle, and we have to find the area of the semicircle. Math challenge for junior and senior Olympiads and all competitive examinations. Math challenge 655. First of all, we determine the area of the equilateral triangle. The formula for equilateral triangle area is given by root 3 by 4 into side square. The side is 6, so root 3 by 4 into 6 square. 6 square is 36, 36 by 4 is 9, so we get 9 root 3. 9 root 3 is the area of this equilateral triangle. Draw the blinking line, vertical line. You can see the dotted line blinking. We draw this vertical line perpendicular to the base. This vertical line perpendicular to the base will divide the equilateral triangle into two equal halves. The two smaller right angle triangles would be congruent. So this dotted line, this vertical line, divides the equilateral triangle into two congruent right triangles. The total area was 9 root 3. So each half would be 9 root 3 by 2. So area of each right angle triangle would be 9 root 3 by 2. Now we draw the radius. We draw the radius. You can see the white line, animated white line. From the center of the diameter, which is also the center of the base of the equilateral triangle. From the center, we draw the radius. You can see the white line. So this will be equal to the radius. Supposing it is r. R is the radius. So we draw this radius. Now we already know that area of each half of this equilateral triangle, that is each of the right angle triangles, is 9 root 3 by 2. You can see the right angle triangle blinking. The radius is perpendicular to the side of the triangle, which is a tangent. The side of the triangle is a tangent, so this radius is perpendicular to it. So if you consider this right angle triangle blinking, then 6 would be the base and radius would be the altitude, right? So if you consider this half of the triangle, this right angle triangle which you can see blinking, then 6 would be the base and this radius r would be the altitude of this triangle. So consider only the half, that is only the right angle triangle, one part. There are two right angle triangles. We consider only one of the right angle triangles. Now base is 6 and altitude is the radius r. So base 6, altitude r, area would be half into base into altitude, that would be 3r. Half into 6 into r, half into base into altitude, that would be 3r. But this area should be equal to 9 root 3 by 2. So we get 3r is equal to 9 root 3 by 2. Dividing by 3 both sides, we get r equal to 3 root 3 by 2. 3r is the area of this right angle triangle, and also the area of the right angle triangle is given by half base into altitude, that is half of 6 into r, that is 3r. So 3r is equal to 9 root 3 by 2. Dividing by 3 both sides, r equal to 3 root 3 by 2. This is the radius of the semicircle. So we got the radius of the semicircle 3 root 3 by 2. Now semicircle area is given by half pi r square. Full circle pi r square, semicircle half pi r square, half into pi, radius 3 root 3 by 2, radius square. 3 root 3 square would be 27. and denominator 2 square would be 4. Now multiply by half, you get 27 by 8 and pi. So 27 pi by 8. 27 pi by 8 is the area of the semicircle. When radius is 3 root 3 by 2, area of semicircle half pi r square, and we get the required area as 27 pi by 8. That was math challenge. Follow us for all school level math, junior and senior Olympiad math, university admission test, quantitative aptitude and numerical aptitude, and all competitive exams. And remember, all our services are entirely free of charge for students all over the world, so students from anywhere in the globe can contact us with their question and their problem. Like and share the video and subscribe to the channel and be with us. We will meet again with more useful videos, more interesting questions. Till then, thank you and goodbye.